thinking about a green roof structure, we come into that project through the idea of thinking about geometry in relation to microclimate. How can we think of a green roof structure that is not only extensive, but has an articulation, a geometrical articulation in the terrain? I think, as well as dealing with an idea of microclimate, because a lot of the green roofs that are out there today are perhaps not monoculture, but they're very simple. Of course, they're very smart. They take care of stormwater in urban context, so that water don't percolate directly into our water cleaning plants, but they actually pass through these green roof structures. They also work with they decrease or reduce heat in urban conditions, which is also like something that is favorable in urban conditions. They are recreational, and there are a set of sustainable aspects, but they're usually pretty not so fun used. So is there a way to kind of come in with a design thinking in relation to this? And that's why we also are interested in linking microclimate with geometry, because depending on how you form, for example, a green roof, you will be able to create microclimates in relation to directions, north, east, west, south, height. If it's if you deal with valleys or small mounds, etc. Like depending on how you differentiate the surface, you can also create these microclimates that are conditioned by geometry. And why we are interested in that is partially because we have knowledge about geometry and 3D modeling in relation to fabrication. So we're trying to somewhat link that with a microclimatic way of thinking, or some kind of biological substance, such as vegetation. A microclimate can be this, for example, which is some kind of algae or lichen on a rock that is affected by the tidal water. So depending on the tide the water is higher, the water is low. This very small microclimate is changing. A microclimate can be a condition in, for example, a marshland or a small marshland. Another word in English is marshland is really big, like smaller, mosse, or in Swedish, and can have a kind of a deep. These have a kind of a deep soil condition, whereas the former ones these plants don't need any soil, then can just grow on the material. And these are things that are interesting. How can we start to think about how synthetic material can meet natural systems, and perhaps they can go between being, like an architecture that is exposing constructed material, if it's glass or porcelain, or if it's wood or stone or aluminum, or then going into these more deeper conditions where you have a deep soil and actually creating almost like a small park or whatever. The Namib desert beetle. Now we are getting to all what you have heard earlier today. Jonas showed a project of a student at AA who worked with the Namib desert beetle to do a green, some kind of a green structure for farming. Yeah, farming in the desert. The Namib desert beetle have these hydrophobic and hydrophilic zones on its very bumpy shell, and the bumpy shells, the tops are depending on the geometry of the shell, we can say, it can direct and collect this fog in different ways. And also, it's not only the geometry or the surface, the articulated surface, it's also the material properties of some regions are very waxy and some are less waxy, so that they can direct these droplets. That who showed that very pedagogically today? You showed that. Your name is Sophia. So you have already, she showed some very good slides about how these droplets, when they perhaps become heavy, either they run off, or usually they run off, and for the beetle they run off, and then he or she, well, I don't know, but can drink it or can get the water the beetle needs. because there is no kind of rain in these deserts. So is there a way of thinking about directing and water in different ways on a green roof, that one creates these different kinds of microclimates, that you also can create more of a perhaps biodiversity on a block size, or I don't know how large, but where you go from different more drier zones to wetter zones, and actually work with that as a design quality, and really think it through as a design quality, and directing water in different ways, both for cleaning water as well as providing water for the structure. The material to the right is research done at MIT, where they have mimicked the properties of the Namib desert beetle with this kind of texture which is bumpy, and have these wax zones and hydrophobic and hydrophilic zones, and so it can direct water in different ways. Okay, so then we have some references. So green roof structures, you have the kind of very classical ones, the vernacular references. We have a lot of them in Scandinavia. This is in Newfoundland and Canada. And what is interesting, I think, is when does the built architecture start to negotiate between the kind of the vegetation, the biological zones. Here's very little. Here it looks like mounds, but we see a window over there.
I'm afraid time is running out. So.
Okay, this is zoomed down. This is more of a contemporary version. Renzo Piano in San Francisco. It's a science museum center. We actually works with this terrain. You see some architecture coming through, but it's a very not perhaps a monoculture, but it's monotonous in its treatment of the green roof quality, which we think is a little bit boring. Then the last thing, building as prototype. So also tying into what Jonas said, we are very interested in finding ways of collaborating and working together. Thinking about prototype not only as a small model, but as something that collects people to create a dialogue. So let's say that I have to collaborate with somebody that we don't share the same language, but if we have something to talk about, if we have either have a model or a prototype, or you have some kind of goal that we somewhat can understand from different sides, perspectives, we might be able to build a collaboration. So we have worked usually with smaller prototypes for exhibitions or scaled prototypes, but now we're interested in thinking about the building as a prototype, as a research project. So we are right now investigating possible actually sites and programs and affiliations, so we can actually build a building as a research project and to create knowledge through that. There are references. AA at London did with the students and some industries, a small pavilion. The Serpentine Gallery in London is a private gallery foundation that every year makes a pavilion in the park. This is Sana Architects. And we have ETH Zurich. It's a technical high school or technical university in Zurich. They are right now building this multidisciplinary refugee, or like a alpine building for both overnight, 120 beds, and a restaurant, etc. And it's a solar. It's a to 92% self-sustaining building. So it's both a design research as well as kind of a interdisciplinary research. It's environmental engineers enrolled, there are structural engineers enrolled, etc., etc.
You said quick at the end. Thank you, Ulrika.